test was written, so I want to make sure that we make those changes. I'll let you know when we get to them. So this says we're going to write a model, or a function that models each variation. And number one, x equals -5 when y equals 3. Y varies inversely as x. So help me out. What does varying inversely look like as an equation? So now what should I do? Plug in the numbers. Because what am I looking for? Yeah. So we multiply both sides by -5 and get -15 for k. Now, unfortunately on this test, there are students that write k equals -15 and go on to the next problem. Is that done? No. Yeah, you got to put it back where it's supposed to go, which is right here. So you have to finish it up. Y equals -15 over x. So it's one of those things, it's kind of a short test. Sometimes people go too fast. Go back and double check. You know, did I forget to write the equation? All right, number 2. X equals 3 and y equals 5 and z equals 6. So pretty much we know this one's a little more complicated. Y varies directly with x and inversely with z. Is there anybody that wants to take a crack at writing that one? You got it, Matthew? Does it bug you that I put kx? So Matthew's going to put xk. But y varies means we have to have that k in there. Directly is multiply. Remember, inversely is the only one where we divide. Now what should I do, or am I done? Yeah, plug them in. We want to figure out what k is. You could notice that 3/6 reduces to 1/2, but you don't have to. You'll still get the right k value in the end. So you could multiply both sides by 6, or you could decide, hey, I'm going to cross multiply to figure out what k is. Either way, we should come up with that number, right? And again, is that done? No, but you've done most of the math. Now you go back and substitute your k value in. So y equals 10x over z. Put a box around it, star it, circle it, whatever, so that I can follow your work and know, hey, that was your final answer right there. Piece of cake tomorrow? Okay. Now remember, they didn't mention jointly here. What does jointly do? If they vary jointly, what does that mean? Multiply. Yeah, because what's the only one we divide for? Yep, any other type of variation, and we are going to multiply. The tables. Been a while since we saw the tables. Is the relationship between the values in each table direct, inverse, neither? And then write an equation to model any direct or inverse variation. Okay, so direct. What's our really short, small, direct equation? Y equals kx. And you already told me the little inverse one. Do you see a k in either one of those tables? So we see x's and y's, which means we have to know what x and y do together. Well, they're not even on the same side right now. So what we have to do is get the x's and y's on the same side of the equation. So this is what we talked about where it's backwards. If it's direct, which is multiplication, we're going to see division work in the table. And if it's inverse, which is supposed to be division, we're actually going to see that when you multiply them, you get the same thing every time from the table. So I don't look at it as a memorized thing. I look at it as, you know, direct is multiplication, you know inverse is division, and then just work with those a little bit. So go ahead and look at 3. Figure out which type of variation that is and be able to explain to me why you believe that's so. Anybody have it? Direct. Okay, Caitlin, what did you see that said this is direct? Everybody see it now? Yeah, we get 2 each and every time. And that 2 is what in our equation? That's the k. So now all we have to do is write the equation. What would our equation look like with a k value of 2? Yep, and then you can kind of double check. I mean, if you're saying that's the formula that's going to work, when you put a 7 in, you better get 14. Put a 10 in, you get 20. Put a 14 in, and you get 28. And it does. All right, same thing for number 4, please. Inverse? Emma, was that you? Okay, Emma, what told you this was inverse? $56 every time, right? So what does that equation look like? Henry? Yep. There it is. Now, unless there's 3 of them on the test, which there aren't, because like I said, this is the test with different numbers, there's only 2, you should expect one to be direct and one to be inverse. You know, we'd like to see that you understand both of those types of variation. So you probably are not going to see a neither, but there are different versions of the test. So, you know, be ready for it. If it's not division, you know it's not direct. If it's not multiplication, you know it's not inverse. Then your only other option is neither. Next up, what is the domain of the following function? Well, we like that one. That's that really easy hyperbolic equation, y equals a over x minus h plus k. And the domain is all about the x's. So the question is there any number that would be bad to use for x? Yeah, 3. Because it would make a 0 in the denominator. So it's as easy as that. You know, what can't I use here for x? X can't be 3. Next one says, write an equation for the translation of y equals 2 over x, but now it has asymptotes that aren't at 0. Its asymptotes are at -7 and at 3. Well, we should be thinking this right here. So the 2 is supposed to stay put, but the asymptotes have changed. So if x equals -7 is the vertical asymptote, what does that mean the denominator was? And if y equals 3 is the horizontal asymptote, where does that have to go? +3 in the back. So again, anything with x is the opposite. You know, we look at that and see, oh, it's +7, but the vertical asymptote would actually be -7. That one's done. Are we already at problem 7? Wow. Okay, number 7. For problems 7 through 9, holes, horizontal asymptotes, vertical asymptotes. That's what we're up to. So I start thinking, well, to see holes, you have to have everything factored, because you have to see whether or not something will cancel or not. So look at number 7. Any factoring we can do with number 7? Well, and I think we just better start answering our questions. Is this going to have any holes? No, we can't cancel those x's because this one has subtraction with it. We can't do that, so none. Don't leave it blank. Leaving it blank tells me you didn't know. But writing none says, I know there aren't any. It's not going to happen. Vertical asymptote, where will that be? And what's the equation you're going to write down? X equals 4. Remember, these are equations for lines. All right, how about the horizontal asymptote? Right. Y equals 0. There it is. All right, let's look at 8. Is 8 factorable? Oh, okay. What can we do on the top? A 4 and an x. Oh, that's interesting. Notice I'm not writing the denominator down yet. Caitlin? Oh, because this one is in the a over x minus h plus k model, you can just use the number that's in back. Now, Caitlin, you actually brought up a good point here, because some people will look at this one and think, well, do we want to use that or not? Oh, that's an x up there. I was thinking it was a number. You're right, Caitlin. We have to use degrees on that one. Thank you for bringing that up. I had in my head the example before it where it was a 2 up on the top. So this one we have to use degrees for because there is an x on the top. If the degrees are equal, what do? Funky fraction. Thank you, Caitlin. There we go. Have to get myself to move from one problem to the next. Alrighty, taking a look at the denominator in number 8. Anybody remember how we can turn that around? Oh, that's interesting. So does this one have a hole? It does. What's the x value for the hole? And now we want to know where it is. So remember, go ahead and do the canceling. So cancel out the x minus 2 and the x minus 2. And you'll get y equals negative 4x. Now, put the 2 in there. What do you get for the y? Negative 8. So we want to know, where's that hole going to be? All right. Vertical asymptotes. At 2? But that's where the hole was. If that was the only thing in the denominator and it's a hole, we don't get any. There was nothing else in the denominator there. All right. Now, this time, definitely not even close to a over x minus h plus k. So we have to use the degrees. What's the degree of the numerator? 2. Degree of the denominator? So think about yesterday. There's none. When the degree of the top is greater than the degree of the bottom, it's none. So just because we're not guaranteed the other ones are going to work out here, I want to make sure you remember those. If the degree of the top is less than the degree of the bottom, what do we write? Y equals 0. If the degree of the top equals the degree of the bottom, what do? Funky fraction. Degree of the top is greater than degree of the bottom. None. And like I said, that's the kind of memorization piece that we do at Algebra 2. We wait until pre-calc and calculus to explain why that works, because you have to talk about limits, which is a calculus thing. All right, I look at number 9, and I'm thinking ahead to the fact that we want to know where the horizontal asymptotes are, and I realize I'd probably want to see that all multiplied out too. So why not just take a second and multiply your denominator. If it's on your face, it can't fall off of your desk. Alrighty. So look back at your factored form. Does this one have a hole? It does, doesn't it? What x value? -1. Now let's actually cancel out the x plus 1's. We'd get y equals 1 over x minus 3. So what will that give us for the y value? Everybody see it? -1 minus 3 is -4. So 1 over -4 or -1/4 for the whole. This time, though, we still have a vertical asymptote because there's something else that didn't cross out. So where would the vertical asymptote be? X equals 3. And the reason I multiplied it out? Just to make sure everybody can do the horizontal asymptote correctly. So what would we put? Degree of the top is less than the degree of the bottom. This is a 1. This is a 2. There it is. So these are just kind of fill in the blank. You know, do you notice that things that cancel are holes? Can you follow the rules that we had for vertical asymptotes and horizontal asymptotes? And then we have to put it all together and actually do a graph with all of these. So again, these are going to be the ones that are worth more points because there are more steps involved to this. But remember, you can use your graphing calculator for the ones you need to. So this one, yeah, we'd want to use a graphing calculator for. This one, I wouldn't recommend it. This is y equals a over x minus h plus k. Yep, 1 second. So what you should have noticed just now is this is not what you have in there for number 10, right? Now, we made some changes to the test, so I want you to cross off the one that you have and replace it with this one. And I want you to add domain and range to your slots for number 11. We tried to make the test a little shorter by putting a couple of different concepts together. That reminds me, I better check that I changed attendance for a couple that came in late. This would be a good time for that. You ready? I think some of you have already started them. So, did you factor number 10 already? Or maybe it's not factorable. Maybe that's what we're really trying to test. But probably is, you know, because we want to see you find holes and asymptotes and all that good stuff. So x squared minus 2x minus 3, how does that factor? How about x squared minus x minus 6? So what are we supposed to see right now when we factored that? It's got a hole. Where's the hole going to be? 3 something. So how do we get the something? So you actually do the canceling. And plug the 3 in. What do we get? 4/5. Now, I don't know about you, but I tend to forget about the hole if I wait to graph it. I'm not going to wait to graph the hole. I'm going to go to 3/4 right now. 1, 2, 3, about right there. And do my best to make a little donut hole. Otherwise, I might forget it. I don't forget the asymptotes, but I have forgotten wholes in the past. So, alrighty, do we get a vertical asymptote? Where is it? Yeah, that's the one that wouldn't cancel. Do we get a horizontal asymptote? Right, because these have the exact same degree, we do the funky fraction. And now is when we stop and put wholes that we didn't remember to put on already. Vertical asymptotes and horizontal asymptotes on the graph. Again, they have to be dashed or dotted, not solid. That is a must. That is something that has been done since math has been around. It's historic. Helper lines are dashed or dotted. You know, all of that would go back to BC times, and we don't have it recorded anywhere, you know. And usually that means, Matthew, that there were different people working on it at the same time, and when they came together, they all went, oh, look at that, we all did dashed or dotted. You know what, that's a really good idea, because those are helper lines, they're not part of the actual graph. So I'm just going to say some really smart guys a long time ago. All right, we need some numbers to put in our calculator, right? So I would say we're going to need some stuff to the left of -2. I mean, that makes sense. So let's try maybe -4, -3. And we're going to need some more stuff for the right-hand side. So -1 and 0 sound like good numbers. Nice small numbers. Get those on there. But again, to get your calculator to graph this right, you have to use parentheses around the numerator and the denominator. Parentheses. X squared minus 2x minus 3. Divided by parentheses x squared minus x minus 6. Zoom 6. So now is when you ask yourself, does that look like it fits with what I had for asymptotes on my graph? Looks pretty good, right? So let's go into the table. And we needed a few negatives. So let me move that. -4 is 1.5. That's a nice number to write down if I can get everything out of the way of my recorder here. -3 is at 2. Should we be shocked that at -2 it says error? That's where we said there was an asymptote, right? That's supposed to be good. So while we're thinking about it, where should we find an error in another spot? Oh, come on. Wake up. There we go. -1 was 0, but -2 said error, and 1 has 0.66667. Why is there an error at 3? That was where our hole was. Yeah. So vertical asymptotes and holes are going to show up as errors. All right, let me get these others down. -1 is 0, and zero is 0.5. So let's put these on here. Now, since this is a test, even though I might not write it down, I might want to see what's going on out here at -10 and make sure that it's really super close to my asymptote at 1. and it is 1.125. And I might want to see what's going on way out on the other end at 10.92, so getting closer to 1. So that absolutely tells me, hey, my asymptotes were on here correctly. And this is going to go pretty close in to that new origin. Now, if you did yesterday's homework, you'll be saying, well, Cedarholm, you didn't ask us for x and y intercept. I mean, we did that on the homework in the last couple of days. It's because we already tested you on that this year. We tested you for x and y intercept in first semester. So we don't need to test you on that again. Done. That's it. We did everything we need to do to fill in the blanks. And we're not going to ask you domain and range on these, although it wouldn't be that hard, right? What x value is out? And the whole, yep, -2 and 3. What y value is out? 1, because that was an asymptote. So we just don't want to ask you stuff like that on the more complicated one. We want to go after that nice a over x minus h plus k problem for that one. Again, this is something we decided to change this year. In past years, we had domain and range on both of them. We're just going to go with one this year. All right, do these fancy little jobs get holes? No, these don't have holes. So again, put none. Don't just leave it blank. Put none. Vertical asymptote, x equals 2. Horizontal asymptote, y equals 1. This one's right in the back. Well, we might as well go ahead and get all that good stuff on there. So x equals 2. Y equals 1. And like I said, with this one, I wouldn't punch it into a calculator. First of all, you're going to need double sets of parentheses for this first fraction if you punch it into the calculator. So you could, if you want to, just to check it, y equals parentheses 3 divided by parentheses x minus 2 parentheses plus 1. But that's kind of silly, because with this one, we just need 2 little points on either side of our vertical asymptote. So give me some numbers that would be nice to work with. 0 and 1. Sounds great. What else? Sorry. Didn't hear anybody come out clearly. 3 and 4, just on the other side of it. Sounds good. And then we just plug those back in. So I'm going to get these parentheses off of here, so that doesn't mess with anybody. Put a 0 in there, and you'll get 3 over -2, which is -1.5. -1.5 plus 1, -1/2. Put a 1 in. 1 minus 2 is -1. 3 divided by -1 is -3. -3 plus 1 is -2. There's one branch. 0, -1/2. 1, -2. Go back and put a 3 in. 3 minus 2 is 1. 3 divided by 1 is 3. And 3 plus 1 is 4. Put a 4 in. 4 minus 2 is 2. 3 halves is 1.5. 1.5 plus 1 is 2.5. Now you have the other branch. So last thing for us to do is, once we've got our graph all there so it's very visual and we can see, hey, this is where we're not graphing, is go fill in that domain and range piece. So what's out for the x's? 2. What's out for the y's? So it's just the opposite of what we have for vertical asymptote and horizontal asymptote. We say you can't use 2 because that's where the vertical asymptote is. You can't use 1 because that's where the horizontal asymptote is. So if this is the test tomorrow, which is very, very similar to what you're going to do, what do you think? Piece of cake? 3 sections? All of it pretty related to each other, so shouldn't be too bad. Shouldn't be too bad at all. So here is your review assignment, and yeah, there'll probably be some graphing in there, so sanitize my hands and get you some graph paper.